Shall we start the program, sir? Shall we start the program, sir? Good evening, everyone. Our esteemed resource person, faculty members, and the participants, welcome to the third day of our International Faculty Development Program on Bridging Creativity with AI, Data Science, and Blockchain. To behind it, my pleasure to invite Mr. S. Murali Krishnan, sir, to deliver the welcome speech. Please welcome, sir.
Good evening, everyone. It's my pleasure. Welcome to all to the International Faculty Development Program on Bridging Creativity with AI, Data Science, and Blockchain. We are honored to have this distinguished faculty and expert with us today. This program is wonderful opportunity to explore how creativity and advanced technology can become together to inspire teaching and research and innovation. A special welcome to our research person, Mr. Patan Feridoz Khan, and our heartfelt thanks for sharing your experience with us. I wish all participate and engaging and insightful session. Let us making the most of this opportunity to learn, the collaborate and innovate together. Thanks.
Thank you, sir, for your inspiring words. Now we will invite our resource person to take us thought today's session. Please welcome him with a round of applause. Welcome, sir.
Thank you, Ma. Thank you, Ma. Am I audible?
Yeah, yes, sir. Audible, sir.
Yeah.
Yes, sir.
So first of all, the thank to the organizers for conducting this 3 days FDP program. So this is the last day regarding the foundations of data science and its application. So before going to start, just a small introduction regarding to me. I am the Patan Feridoz Khan, Assistant Professor in the Department of CS in the Mohan Babu University, Andhra Pradesh. So totally, I am having the 16 years of experience in the School of Computing. So I have published four international conferences papers, scopus, and two journal papers. Okay. So coming to our FDP. So today the topics are. Yeah, my screen is visible, ma?
Yeah, yes, sir. Visible, sir.
Yeah, yeah. Okay, thank you.
Okay, sir.
So in this session, we are going to discuss about. So in this session, we are going to discuss about what is meant by a data science, what is meant by a data science, the key components of a data science life cycle, the types of data, mathematical foundation, applications of data science, real world case study, ethics of data science, and the challenges and the future trends of the data science. So these are the different item lists that we're going to discuss today, FDP. So what is my data science? Key components of a data science life cycle, types of data, mathematical foundation, applications of data science, real world ethics, challenges and the future trends. First, coming to the definitions of a data science. What is meant by data science? A data science, it is a interdisciplinary fields that combines mathematics, statistics, computer science, and domain knowledge. So this data science is a interdisciplinary fields that combines statistics, mathematics, computer science, domain knowledge. So statistics means it is related with the stats, mathematics as you know, computer science as you already know. Then coming to the domain knowledge. What is meant by a domain knowledge? So what is meant by a domain knowledge? So a domain knowledge which is used to understand the specific field or the industry or any other subject area in which data science is applied. So that their domain knowledge, it is referred to the specific field or industry or a subject area. So generally in this domain knowledge in the PhDs or we are asking the what type of a domain we are using. So like this domain knowledge. So next coming to the, it is the goal to extract the meaningful insight from the data and support decision making. So coming to the components of data science, there are majorly different components of data science we are having. That is the data collection, data cleaning, data pre-processing, and the next one slides we're going to discuss. So data collection, what is the data collection? So this data collection is nothing but gathering the raw data from the databases, sensors, websites, social media. So here we are going to be collect the raw data. Raw data means it will consist of noises, it consists of meaningful data, all the raw data it will consist. So where we are getting those, all those data means databases from the sensors or any other websites or any other social media. That's the data collection where we are collecting the data. Next, after collecting all those data, we have to clean all those data. Why we have to remove all those data? In order to avoid duplicates, some missing values, and normalizations. So if we are having any duplicate values, so same names, duplicates. If you are going to missing any values, so here we have to data cleaned. Next, mathematical foundation. In this mathematical foundation, here in this data science, the mathematical foundations were mainly concentrate on the statistics, linear algebra, calculus, and the optimization. So statistics means here we are getting the mean, median, and the variance. What is meant by a mean? A mean is nothing but it is the sum of all values which is divided by the number of values. So general mean. So general in the mathematical statistic we are having the mean values. What is my mean means? Here we are going to be add that is the sum of all values divided by the number of values. Then what is by median? Median is nothing but middle value where data is arranged in a ascending order. Where data is arranged in a ascending order. That is a median. Then what is meant by variance? Variance means how the spread out those data from the mean. So whatever the data that are going to spread out from the mean values, those are all comes under the variance. Next, coming to the probabilities distribution, as you already know. Then linear algebra. So in this linear algebra, we are going to vector, matrices, matrix operations. Those are all comes under the linear algebra. And finally, in the calculus and the optimization, we are going to discuss about the gradient descent derivatives for the model training. In this mathematical foundation, statistics, linear algebra, calculus, and the optimization. Then machine learning basics. In this machine learning basics, we are having the two types of basics. Those are the supervised learning, and second one is the unsupervised learning. Supervised learning, and second one is the unsupervised learning. What is meant by a supervised learning? This supervised learning, it is a type of machine learning where models is trained using the labeled data. Then what is meant by labeled data? Each input having the corresponding correct output. So supervised learning, it is a type of ML where model is trained under labeled data. So labeled data means here the each input having the corresponding output. For every input, we are getting the corresponding output. Then in this supervised learning, so here I have given the models learn from the labeled data, regressions. What is meant by regression? Some we are going to be predict the numbers. Then classifications, we are going to be predict the categories. Coming to the unsupervised learning, it is also type of ML where model is trained on unlabeled data. System does not know the correct output. So in previously supervised learning, we are getting the correct outputs. But in the case of unsupervised learning, we are not getting any correct outputs. Here, that's why I have given no labeled data, clustering, dimensionality reduction. Then here, what is by clustering? So clustering, it is a unsupervised learning technique which is used to group similar data points into the clusters based on some patterns. So it is a unsupervised learning. So clustering that comes under the unsupervised learning. So which is used to group the similar data items. Here not we are grouping the dissimilar items. We are going to be group the similar data items into a cluster based on patterns. So all we are going to be group into a some group. So that group we can call as a cluster. Then dimensionality reduction. What is meant by dimensionality reduction? It is used to reduce the number of input variables in a data set. So it is used to reduce the number of input variables. Whatever the input variables, it is going to be reduced in a data set. Next. So in this machine learning basis, we are having the supervised learning. Another one is the unsupervised learning. Next one is the tools and techniques what we are going to be used. So in these tools and techniques, so the common tools we are using Python, R programming, NumPy, Pandas, then Jupyter Notebook, then Table, Power BI. So all these are all the common tools that are used in the data science. So the Python, so R programming, NumPy, Pandas, so Notebook, Jupyter Notebook, Power BI, these are all the common tools and techniques that are used in the data science. Then in this big data tools, we are using the Hadoop, Spark. So these are the two tools that are used in the big data. Coming to the cloud platform, we are having the different cloud platforms we are having like AWS, Azure, Google Cloud. Those are all comes under the cloud platform in the data science. So the tools and technology that are used, the common tools and the big data tools and the cloud platform tools. Next. Now we are going to discuss about the data science life cycle. The life cycle of a data science. We are having the different life stages out there in the data science. The very first stage is the problem definition. Second stage is the data collection. First, coming to the problem definition. In this problem definition, before working with the data, first we have to identify what type of problem it is, how to solve those problems, what decisions are need to be made. what business or research goals are involved. So these are the different problems will first arrive. So before going to start any work, we will get the different strike off problems. So when you have to submit this task, so for example, in academics also, if HOD tell uh, this has to complete to by tomorrow, means that they'll ask, sir, madam, tomorrow only we have to complete this task. How many time we can take to complete the task? Only one person has to complete, or a multiple person can involve this. Like every, we are getting the number of questions. So like that only. What is the problem we are going to trying to solve, and what is the decision need to be made? And coming to the examples for this problem definition, here we are going to be predict customer chance, forecast sales, detect. We are going to detect the diseases. So this all comes under the problem definition. Then second one is data collection. In this data collection, we are going to be gather all relevant data from the multiple sources. So what kind of multiple sources in the sense? Databases, sensors, IoT devices, surveys, third-party data sets. We are collecting the data from the different modes of sources. So the what type of sources means databases. We can collect the data from the sensors. We can collect the data from the surveys, from the logs, from the documents. Next data size life cycle. The next one is data cleaning and the pre-processing. So in this data cleaning and the pre-processing, we are going generally the raw data is very messy. Messy in the sense it is a noisy. It may contain the original data, it may contain the duplicate data, it contains any raw data, anything. So this phase we are going to be clean all those data and collecting some useful information. So that in the we already know about the data mining. What is meant by data mining? So data mining which is used to collect the data, collect the data from the noises. Okay. So here with these phases we are going to be include remove the duplicates, handling the missing values, fixing inconsistent formats, normalizing or standardizing the data, encoding categorical variables, outlier the decision detection. This is the most time consuming step. So among all those 6 steps are there. So this third step is a data cleaning is a time consuming step. Why? Because we have to remove all those messy data from the raw data. So next slide is here we are going to be exploring the data and EDA it is showing exploring data analysis. In this exploring data analysis, we are exploring the data analysis. Here, we have understanding the data through the statistics and the visuals. We are going to be extracting the data through the statistics and visuals. Summary statistics, distribution analysis, identifying the patterns and the trends, and the plotting graph. We are having the different types of plotting graphs like the scatter plots or the histograms or the heat maps. Here we are going to be explore the data analysis. Coming to the next cycle, the next phase of the data science life cycle is feature engineering. In this feature engineering, we are going to discuss about the preparing the right inputs for the modeling. Preparing the right inputs for the modeling. So in this modeling, from among those modeling, we have to select the best variable and we have to extract those data from that variable. We have to extract those data. Then model building. In this model building, different types of models we are getting like regression model, decision trees, random forest, SVM, neural networks. Regression models, decision trees, random forest, SVM, and the neural networks. So in this, what is a regression model? This regression, it is a machine learning technique which is used to predict continuous outcomes which is based on one or more input variables. So generally, this regression model, it is a one of the machine learning technique. It is used to predict the continuous outputs that are based on one or more input values, variables. Then coming to the second one is a decision tree. In this decision tree, it is a supervised machine learning technique which is used for both classification and the regression task. So previously the regression model, it is used to predict only the outcomes from the one or two input variables. But in the case of decision tree, here we are getting both classification and the regression task. And the next model is a random forest. Here in this random forest, it built the multiple decision tree and combined their outputs for more accurate. So in this random forest, it is going to be collect the data from the multiple sources, which we are getting the exact accurate result. The next model is a SVM. SVM is a support vector mission. SVM stands for support vector mission. In this support vector machine, which is used for classification and the regression, So SVM stands for support vector machine, which is used for classification and regression. And neural network, as all we know. So these are the different model buildings we are having: the regression models, decision trees, random forest, SVM, and the neural network. Coming to the next phase of the data science life cycle is model evaluation. In this model evaluation, accessing how well the model perform using the metrics. We're getting the accuracy, the precision, the recalls. Okay, these are all the model evaluation is mainly it is concentrate on the regressions. Next. So coming to the data science life cycle, the next last two phases are the deployment, monitoring, and the maintenance. The last two phases of data science life cycle is a deployment, monitoring, and maintenance. What is one way deployment? Deployment, it is making the model, available for the real use. It should be for the access by all. APIs. API is the application programming interfaces, which can be accessed by all. Web apps, which can be accessed by all. Cloud deployment, AWS or Azure or Google service providers, which can be accessed by all. And integration with the business systems. So deployment here, we are going to be making the models which is available for the real use. Monitoring and the maintenance. In this monitoring and maintenance, it is used to model the degrade over time due to the data drift, concept drift, or any other new trends. So monitoring and maintenance. So these monitoring and maintenance, we are going to be mostly these monitor different types of drifts are available. Those are all the data drifts, concept drift, and the new trend. Next, different types of data. Here the data is of different types, that is the structured, unstructured, semi-structured. What is meant by a structured data? The structured data, it is a highly organized. It is having some follows a fixed schema. Schema in the sense rows and columns. It is easily stored in the database. That is the SQL. So if we consider the MS Office, if you see in the MS Office, they are having the MS Excel. In this MS Excel, what's the purpose of MS Excel? For the calculating the mathematical operations, for any creating any tables, no mismatching of everything we can do. So here the structured data, it follows that one, MS Excel. It having some fixed schemes, some rows and some columns. So example for this structured data is Excel sheets, employee tables, financial records. Then coming to the unstructured data. Coming to the unstructured, so structured means it is having some fixed schemas. Coming to the unstructured data is it is no predefined format. It is having no predefined format. No predefined format means everyone will follow their own format. Hard to store and analyze. So where to store and how to analyze those data is very much difficult. Coming to the examples for this unstructured data is text document, images, videos, social media posts. So text means everyone can use the different formats. So text in the sense someone can use a MS Word, some can use the Notepad, some can use the WordPad like the text document. Images, some can use the JPGs, JPEG, some can use PNG like this. Videos, MP4s, MP3s like this format. Social media posts. So structured means it is having some fixed format. Unstructured means it does not having any fixed format. Then semi-structured. So semi-structured means it is the partial of both structured and the unstructured. Not fully structured, but having the tags or the markers. It is having the flexible format. It is having the flexible format. So example for this semi-structured data is XML, JSON, web page. So XML is an extensible markup language. So for creating the cascading style sheets, or we are using this XML. So the XML, the JSON web page, this all comes under the semi-structured data. Then next topic is mathematical foundations. So mathematical foundations, we are having the three types of mathematical foundations. Those are linear algebra, probability and statistics, optimization basics. Linear algebra, probability statistics, optimization basics. First, linear algebra. So the linear algebra, it is an essential because most machine learning algorithm internally use the vectors, matrices, and the matrix operation. So if you see in the linear algebra, mathematical, all these algorithm, they are using the vectors, matrix, and the matrix operations. So the main in this linear algebra, we are going to discuss about the scalars, vectors, matrix, like matrix multiplication, dot product, cross product, this is matrix multiplication, vector spaces, this all comes under the linear algebra. Applications in this data science are representing the data sets as matrix, feature transformation. The PCA is the principal component analysis. The PCA is the principal component analysis. These are the applications in the data science regarding the linear algebra. And calculus, we are having some other applications. And vector and calculus, we are having some other applications. In this linear algebra, these are the applications. So representing the data sets as a matrix, feature transformation, principal component analysis. Next, probability. So probability, which is used to predict the livelihood of an event. Which is used to predict the livelihood of an event. That is a probability. The concepts that are the random variables, the concepts that are random variables, probability distribution, conditional probability, and the Bayes theorem. These are the these are the key concepts of the probability. Random variables, probability distribution. In this probability distribution, normal, binomial, Gaussian, these are the different probability distributions. Conditional probabilities and the Bayes theorem. Next, statistic, probability, statistics. Next one is a statistic here, which is used to analyze and summarize the data. Here in this statistic, we are going to summarize the data. As I already discussed, mean, median, mode, this all comes under the statistics only. Variance, standard deviations, quartile, this all comes under the statistics. Coming to the applications are understanding the data behavior, future selection, and building probabilistic models. So here in these applications regarding the statistics or the understanding the data behavior, how the data is going to behave, feature selections, and building probabilistic models. Next, coming to the key concepts of optimization basics are it is the functions and the limits, partial derivatives, the chain rules, the gradient descents. So partial derivatives, so the derivations, all those are all comes under partially, and the chain rules, it is going to be surpassed from one formula to another like that. Then applications regarding these optimization or the training the neural network, back propagation, and tuning the multi-modal parameter. Then coming to the applications of data science. So coming to the applications of data science, so majorly the different areas these data science applications has been used. First one is a healthcare. Next one is a finance. Next one is a retail. Next one is a data manufacturing. Next one is agriculture. Next one is a government. These are the different applications in this the data science has been used. So there are some other areas also this data science is used like e-commerce or agriculture, in finance, in transport. All this one also used, but I have used it very little to convey. I would use it this one only. So coming to the healthcare. So in this healthcare, how this data science used? It is for the disease prediction or the medicine and the drug development. So the process of creating a medicine is very difficult and it is a time consuming. So it is a fully disciplined, you have to create the process of a medicine. So without the data science, it takes a lot of time. Here the resources, the finance, new medicine drugs, with the help of the data science, it becomes very easy because the predictions of the success rate can be easily determined based on biological data. So in this, the healthcare, the healthcare, it is very plays a very crucial role regarding the data science. Next, coming to the finance. In this finance, fraud detection. So the data science plays a very key role in the data science. So the finance industries always have a issues of frauds and the risk of losses. So thus the financial industry needs to automate the risk of the losses analysis in order to carry out strategic decision for the company. Also, sometimes the financial industries uses the data science analytics tools in order to predict the future, how the future trends are going on, like that. It allows the companies to predict the customer lifetime values and the stocks market moves everything. So the coming to the stocks or any SIPs, mutual funds, all this comes under the in this finance one. Next one in retail. In retail is a recommendation system. In this retail, the mainly is e-commerce. So in this e-commerce, how this e-commerce websites like Amazon or any other Flipkart, which uses the data science to make the better use experience with a personalized recommendation. For example, if we search any something data on the e-commerce website, we get a suggestion, we get a recommendation. Okay, so similar to choice according to your past data, and also we get the recommendation according to most buy the product like that. Okay, na? Retail. Then Manufacturing. In this manufacturing, predictive maintenance. In this manufacturing, predictive maintenance. Next one is agriculture. In this agriculture, it plays a very key role regarding the crop yield production, regarding the what we say, uh, regarding the rains or any other drugs that has been used for the cultivation of the plants, everything. And the last one is government. In this government, smart cities, public services, all this, one of the government will plays a key role in applications of data science. Next slide. So real world case studies. So in these real world case studies, the three main case studies are there. That is the disease prediction model, disease prediction model, then fraud detection model, the disease prediction model, detection model, and the recommendation engine. First, disease prediction model. What is the disease prediction model? In this disease prediction model, it is used to predict the disease management using the data based or a process based approach to analyze the factors of the weather, whether it is what type of levels are being used, and the host and the susceptibility. So common model include the historical data or any other data, biological process, which can be combined into the hybrid model. Here we are going to be detect the early cases of the diseases. Here we are going to be detect early cases. Then personalized treatment recommendation, risk assessment for the chronic condition, and reducing the healthcare cost burden, support doctor in the diagnosis, identifying the high risk pattern. Next, the common steps in the building the disease prediction model are: first one is a problem definition. First, we have to identify the target diseases, whatever the disease is came, and the data collection. So, data collection, we can collect the data from the images or any sensor data. And the data cleaning, we are going to be data clean by what we are going to cleaning means the missing values or the duplicate values. Feature engineers means medical features, the risk scores, and the training and the validation, cross validation, hyperparameter tuning, and the model evaluation. Next, in this real world application, the banks, how these banks occur in the what type of challenges we can say credit card frauds. So credit card frauds. So credit card fraud, these are all the one of the major issues. So this credit card fraud detection uses the machine learning to identify the suspicious transactions, typically involving the data pre-processing, typically involving the data pre-processing, handling the imbalanced fraud, building the models, evaluating the performance. These are all the different modes of the credit card frauds. And regarding the insurance also, claim frauds, e-commerce, some fake accounts are created, return frauds, telecom, the SIM swap, one person having the multiple SIMs like the SIM swaps, identity frauds, and regarding the healthcare, the billing frauds. So objective of the fraud detection system is detect fraud transactions, prevent the financial losses, reduce the false positives, provide the real-time alerts, support the risk assessment. So in this, these are some basic objectives of a fraud detection methods. So we are going to detect the fraud transaction. What is a fraud transaction? So some amounts are being fraud here and there. Next, to prevent the financial losses. So we can reduce false positives, provide the real-time alerts to the customers, like that. Next one. So this recommendation engine, the recommendation engine is an intelligent system that analyzes the user behavior preferences. Recommendation system, that is an intelligent system that analyzes the user behavior preferences and the data pattern to suggest the relevant items such as products, movies, musics, articles, services, like this. These systems are widely used in e-commerce, streaming platforms, like this. So a recommendation engine, it is an intelligent system, if you see, that mainly depends on the user behavior. This recommendation engine, it is also ML that uses the algorithm to analyze the user data to suggest the relevant items such as products, content, or the services. Applications of these real world case studies are e-commerce, that is Amazon, like this, Amazon, Netflix, like this, streaming platforms, Netflix, YouTube's, music apps, Spotify, we can or any other apps, social medias. So social media means Instagram, these are all the news platform. We are having the number of news platforms. Then ethics in the data science, the ethics in the data science for the data privacy, bias, responsible AI. First, data privacy. So, this data privacy refers to the responsible collection for the storing and processing and sharing of the personal data, while ensuring the individual information is protected from the unauthorized access and misuse. So, generally, the user control over their own data and ensuring organization handle the data ethically and legally. So generally this data privacy is responsible collections, storage, processing and sharing of the personal data information. So why this data privacy occurs? So why? Because it protects the individual from the data identity thefts and the frauds. Generally, it maintains the trust between the user and the organizations, and it prevents the misuse of the sensitive informations. Generally, it reduces the legal and the financial risk for the business. Bias. This is another ethics in the data science. So bias, generally it is a systematic error in the data, algorithm, or the decision making that leads to the unfair outcomes for the certain groups. Bias and fairness. This fairness, it is used to ensure the AI model where we want to treat all individually equally without discrimination based on the factors such as the gender or any caste or any other age or any other disability or any other economic background or any other physical appearance. We should not use any discrimination regarding that is a fair. Then here in this types of bias, we are having the two types of bias. That is the data bias and another is the sampling bias. What is a data bias? So this data bias, it occurs when the data set does not represent the real world population. Real world population. So example for this one is a medical data set. A medical data set mostly consists of male patient leading to the inaccurate predictions for the female. So generally in the, if you say if, gynecology is like that something if you take, so there actually ladies faculties should be there actually. Here we are, there actually male faculty something there. That's it. Next, sampling bias. So it is used to collect the customer feedback only from the urban users. So next is the last topic, responsible AI, which is used to refer the development and the use of artificial intelligence that are the ethical, safe, transparent, fair, and accountable. Why this responsible AI is important, we can say, is we can build the trust with the users and the stakeholders, support the safe innovation, supports the safe innovation, and ensure the compliance with the law and the AI regulation. Ensure with the law and the AI regulation. Next, so the challenges of this data science are poor data quality, lack of skilled professionals, ethicals and the privacy issues, model interpretability. So what is a poor data quality? We are getting the data is very poor actually. So the data it is we are getting as a messy data. So in order to divide those messy data, we are getting the data as a poor quality and lack of skilled professional. In this data sense, we are having the lack of skilled professional, and it is having any less ethical and the privacy issues. The future trends of data science are the future trends of data science, generative AI, auto ML, edge computing, responsible AI. So these are the future trends regarding the data science, generative AI, auto ML, auto machine learning, edge computing, responsible AI. Finally, the conclusion what I have got to conclude is this data science it is very transformative, interdisciplinary nature, and high demand in the industry. Thank you. Thank you, one and all. Mm. Organizers, are you there? Organizers, are you there? Anyone, please respond.
Yeah, yes, sir.
Yeah, yeah. My session is completed, ma.
Yeah, okay, sir. Thank you, sir, for an insightful session. To conclude, we invite Mr. J.J. Sandipapa to deliver the word of thanks. Welcome, sir.
Sorry, ma'am. Sorry for interruption.
Okay, no
Good evening to
issues.
all. Respected dignitaries, our esteemed resource person, dear colleagues and participants. It's my privilege to deliver the vote of thanks as we conclude the third and final day of our International Faculty Development Program on bridging creativity with AI, data science, and blockchain. Firstly, I sincere and to thanks to our resource person, Dr. Patan Feridoz Khan, your session. And today was both enlightening and inspiring. You not only simplified complex concepts but also encouraged us to think creatively about technology and its possibilities. Your insights will surely guide us in applying AI, data science, and the blockchain more effectively in our work. I would also like to thank Mr. I.S. Murali Krishnan for his warm and engaging welcome speech that set the perfect tone for today's program. A big thank you to the organizing team and the LKP Academy team, especially the Department of Research and Development team in the LKP Academy. We are also grateful to all participants and the faculty members for their enthusiasm, insightful questions, and active engagement. And active engagement. Finally, my sincere thanks to our support staff, volunteers, and partnering institutions, including IRIPA and LKP Academy team, for their support in making this program possible. As we conclude, let us carry forward the knowledge and inspiration we gained over these 3 years. May we continue to innovate, collaborate, and apply these things to create a future where creativity and technology go hand in hand. Thank you once again for your valuable presence and contributions. Thank you all.
Thank you, Ma. Thank you, thank you.
Thank you, sir.
Thank you all. Thank you so much, sir.